Hi, this is Calvin Cox. It is September 25th, 2013. It's 8:12 p.m. and it is Wednesday night. Now, I usually try to do my talks on Thursday night, but because there's so many things I'm working on, and if I get hot on an idea, I have to follow through and try and make a recording on it and then try and go post it on YouTube. Because there's just too many things I'm always constantly thinking about and trying to research at the library and put it together in my head. Does this make sense? I don't know. We'll look for maybe other more conclusive proof, whatever. Conclusive proof, or just working on a hunch, whatever the case may be. One second. Whatever the case may be, I feel I need to do a recording tonight. It's one night earlier than I normally like to, because I like to try and stay in like a pace. But there's just too many things got to do. I got to finish this thing on showing an idea about shading houses, and then I need to make a list about things that are heat inputs into our planet. I mean, just on and on and on and on and on. It's like it's never ending. So when I get hot on an idea, I'm gonna have to run with it, and I can't stick with the Thursday night thing for sure anymore. I don't know. I just have to see how much energy I have and how long I can keep going, I guess. What I want to do here is matter, I think, is composed of, well, we know that matter is just basically composed of electrical fields, okay? We don't know exactly what it is that holds the electrical field. I don't think anybody knows that. I guess there's some theories out there. It would take me forever to research them. That's not the point. The point is, I got some ideas to put out, and a very basic thing that I'm trying to say is that photons transfer or transport weighable matter. And I've already said that before in one of my previous talks. And that's actually pretty critical to determine that, because I believe photons transport weighable matter. If they do, then that can have a very realistic impact on what are certain other things. At this point, I believe that in some cases photons emanate from electrons, excited electrons, and they say they're excited in an expanded state, and when they go back to the next lower energy level, then they give off photons. But I am believing that it's not just a photon that's being given off. The electromagnetic wave is not just light. It's actually a weighable physical particle, but it is so small, and you would need so many of them, that it would take you quite a while with an incredibly tightly controlled experiment to actually prove and weigh something that, yes, in fact, when it was bombarded by visible light, photons, for a long, long time, and when you actually took this item and weighed it again, still it would show an increase in weight, but it would be a very, very, very small increase. So the photons, yeah, they do transport matter, but still it's a super small amount. So I'm going to get on with what I'm talking about and throw my idea about how to create such a device. And of course, if someone ever picks this idea up, if they find it, they decide to try it and do something with it, it's probably going to take a lot of funding to do it, and it's going to take some real finesse and skill to pull it off, because I don't think it's going to be easy to do. The thing about weighable matter like metal and glass and all kinds of other stuff is that they have grain in them, okay? And that grain can hold moisture, and that moisture has a weight to it. So, you know, this experiment would need to be so incredibly controlled in every single way. How, let me get onto it. Okay, so let's go over here. Experiment to determine if photons transport weighable matter. Okay, what I'm gonna propose that you use for this is simply hydrogen gas and let me see, might be something else somebody would want to use. A researcher looking at this might say no, it's better to use something else. I'm just proposing that someone use hydrogen gas and oxygen gas and have both of them go together to produce a flame, which of course the flame will produce a photon. And if it's determined eventually that I'm correct, then that photon would actually be carrying a minute particle of water. Okay, or it actually might be eventually determined maybe it transports just oxygen or just hydrogen. I don't know. But so my idea is this: you have an oxygen source. Ah, damn it! I gotta get a marker that works. It would help. Okay. That piece of junk, let me throw in the trash. Okay. Is that you would have OXY source, hydrogen, H2 source. Okay, they would come together here, create a flame. The flame would give off photon waves and go and then into what I'm proposing would be a glass sphere. Okay, let's say the glass sphere is here. Okay, and that inside the glass sphere is a square metal box that would be painted a dull black color. The idea is you do not want any photons, any visible light emission that's headed this way. When it strikes this, you do not want it to be reflected away. Okay, that would defeat the purpose of this experiment. So you want it to be black, flat black, perhaps of a metal that's naturally black, or something that's painted. Maybe you want the metal shaped in a, like something that would catch the rays as they come in. Also, the shape might have something to do with it. Have like an indented area that the light goes into. Anyway, you want this. It's going to have this metal, whatever it is you decide to make. It's going to have to be figured for size and shape, and then you're going to want to paint it or whatever, and then seal it in a glass sphere. I'm just trying to think of something that, you know, would probably be fairly easy to make. Maybe glass would want to be a square, but you're going to have to seal it somehow. And that seal is going to have to be damn near perfect. Okay. I don't know if you want to put the thing under a vacuum or not. I don't know if you want in here to be under a vacuum and then seal it and then have it be in another container. Okay. But this whole unit right here, you want it small enough where you can, when the experiment is done, you can remove it and weigh it. Okay. You don't want, I don't think you want something the size of a room, and you probably don't want something just the size of your fist. You want something about, I don't know, about so big. And something you can work with. So the photon emission, maybe because light has a tendency to stretch out or expand as it goes, maybe you would want a large lens here to redirect the light back on a smaller area. I'm not sure. I'm not sure what the distance from here to here should be or any of that. All I know is that I believe after the oxygen and hydrogen burn, the flame gives off photons, and those photons manage to get into this black area and be absorbed by it. You might have to have this flame be very intense in sending off a heck of a lot of light for a long, long time to get it to come over here and build up enough matter to actually be weighable. One big problem that I see right here is if you end up having this source too close, okay, these light waves could actually carry enough heat with them. The infrared waves that are in there could carry enough heat to heat this up inside. And I don't think you want that. So maybe there would need to be like a tank of cooled water that the light would travel through, and that cool water would absorb the heat off the infrared. So any heat that's in these light waves, I don't think you want to make it into this area, because heat would also cause an expansion of the gases in here. That's why I'm saying maybe you want to have it in a vacuum so you don't run into that problem. I'm not sure. The people who rig up experiments all the time would probably know exactly how to work all this. But it's just an idea I'm throwing out there. I'm pretty sure that is actually the case. Actually, I'm very sure of it. But the problem is the time and the difficulty it would be to make a container that is accurate enough, and you would have to weigh it super careful beforehand. It would have to be in a very environmentally controlled situation, so it could not possibly gain any moisture as it was being assembled and sealed. And I don't know if it were in a glass sphere. I'm assuming someone would have to make a super accurately, super tight fitting lid, and that actually maybe this glass sphere would want to have one flat side on it so that the light would more easily transfer straight into this metal area here. And then so you could cast it this way with one flat side, and it would need some kind of holder to hold it here from falling over. And then as you put the thing inside there, the metal inside the sphere, and you could put the top on, and then I guess you would heat up with a torch the metal to where it's liquefying, and maybe add a little glass and seal the whole container that way. And then after that's done, I'm guessing you would weigh it and then start your process of transferring photons to it. But I'm very sure it would yield something that weighs more. The problem is proving it. Anyway, so that's my deal. 15 minutes from that.